Hello everybody, elastic collisions, no problem. Let's solve it in the easiest way. So we have this problem, a projectile of mass m moving with velocity v0 collides head-on and perfectly elastically with a stationary block of mass 3m on a frictionless track. What fraction of the projectile's initial kinetic energy is transferred to the block? So in the elastic collisions, it's a headache to solve the quadratic equation. So we now derive the easiest methods to solve two-body 1D collision. So let's generalize it. So we have two bodies which is collide. This is before collision, let's say, and this is after collision. So as we know, in this case, the energy is conserved and momentum is conserved. So first we have the body with velocity v1, and then we also as well have v2, and the masses are different, m2 and m1. If the masses are the same, then it's not a problem, but if the masses are different, so it will be a little bit difficult. So and then v1 prime, after the velocity after collision is v1 prime, and velocity of second object v after collision v2 prime, and mass is m2. So we will here write first the conservation of momentum and energy, which is fundamental here. First, conservation of momentum, m1 v1 plus m2 v2 equals to m1 v1 prime plus m2 v2 prime. At the same time, we also have conservation of energy, v1 squared plus 1 over 2 m2 v2 squared. And this is all the energy these two objects have, because they have kinetic energy and they will not change their this height, or they will not change their position in z direction, their height. So their potential energy will be the same always, so they will subtract each side. So they all have kinetic energy here. 1 over 2, after collision we will write 1 over 2 m1 v1 prime squared plus 1 over 2 m2 v2 prime squared. So we have these two equations to solve this problem, but let's make it easier. We don't have to always solve these two equations. We can make it very easy, very short, and very handy. First, let's move this first part of first term on the right hand side of the equation to the left, while this one to the right hand side, and it becomes m1 v1 minus m1 v1 prime equals to m2 v2 prime minus m2 v2. So we can make like m1 to the outside of the bracket, v1 minus v1 prime equals to m2 v2 prime minus v2. So we have this equation from the conservation of the momentum, and now we will do the same here, but with the conservation of energy. To the left side, this equation to the right hand side, and it will become 1 over 2 m1 v1 squared minus 1 over 2 m1 v1 prime squared equals to 1 over 2 m2 v2 prime squared minus 1 over 2 m2 v2 squared. So we can they all have the same coefficients in front of them, 1 over 2, and it will cancel out. And then if we make outside this m1 of the outside of the bracket, then it will become 1 squared minus prime squared equals to m2 v2 prime squared minus v2 squared. And now, as we have from algebra this equation, we will use this formula, plus b a minus b, and we will use it here for this and for this one, and it becomes m1 v1 minus v1 prime v1 plus v1 prime equals to m2, v2 prime minus v2, v2 prime plus v2. So from the conservation of energy m1, v1 minus v1 prime equals to m2, v2 minus v2 prime. So as we have here the same quantity, if v1 minus v1 prime or v2 prime minus v2 are not zero, let's say momentum is not zero, then we can make it like they are equal to each other. From the conservation of momentum, we will have they will cancel out each other. If they are not zero, then we will have v1 plus v1 prime equals to v2 prime plus v2. We have this beautiful and elegant equation, but let's make it something which is meaningful. Let's take this v2 prime to the right hand side, this one to the this one. I'm sorry. So here, let's take this one to the left hand side and v primes to the one side, and then it becomes v1 minus v2 equals to v2 prime minus v1 prime, or v1 minus v2 equals to minus v1 prime minus v2 prime. So in case of these two bodies, let's find their relative velocity. Then it becomes relative velocity of v1 becomes v1 minus v2, and the relative velocity after the collision becomes v1 prime minus v2 prime. So what says this equation to us? It says relative velocity's magnitude will be constant, but the sign will be changed. So it means relative velocity reverses. So we have these beautiful equations. First equation, conservation of momentum, and relative velocity reverses equation as well. Sorry. Let's solve the above equation using this one. So we have v1 equals to v0, v2 block velocity equals to 0, m1 equals to m, m2 equals to 3m. Now we can solve the problem. You can read it here, you can pause and read it, and then let's put everything in order. m1 is m, we know v0 plus m2 is 3m, v2 is 0 equals to m, v1 prime plus 3m, v2 prime. And next one, v1 is v0 minus v2 is 0, as we wrote, equals to minus v1 prime minus v2 prime. Now this above have the same coefficient in front of each term, so we can cancel m's here, and then we will have v0 equals to v1 prime plus 3 v2 prime, and v0 equals to v2 prime minus v1 prime. Now we can solve this set of equations. We can add them together. We will have v0 plus v0 equals to v1 prime plus 3 v2 prime plus v2 prime minus v1 prime. So these will cancel each other, and we will have 2v0 equals to 4v2 prime. Now we have found v2 prime equals to 2v0 over 4. So it will be 1 over 2v0. And now we can find how many percent. Let's read the last part. What fraction of the projectile's initial kinetic energy is transferred to the block. First, we will find total first initial kinetic energy of the projectile, mv0 squared over 2. And kinetic energy of 3m block, let's say 3m v2 prime squared over 2. Then 3m v2 prime equals to 1 over 2 v0 squared over 2. We will have 3m 1 over 4 v0 squared over 2, or 3 over 4 we can write in front of them, and then m v0 squared over 2. As we see, this is the initial kinetic energy of projectile. We can put instead of this one this tm. T3m equals to 3 over 4 tm. As we can see, the 3m over tm equals to 3 over 2. So 3, that's in percents, it will be 75%. 75% of the energy is transferred to the block. Thank you for your attention. Subscribe for more videos.